In this video, we're simply going to look at binomial key equations. These are the worst case scenario questions you can ever find whenever you're dealing with binomial expansions. So question 1 simply says, in the binomial expansion, 1 plus x over k raised to the power n, where k is positive, the coefficients of x and x squared are equal. We need to show that 2k is equal to n minus 1, and when n is equal to 7, we need to determine the value of k. So now I'm going to take my time to explain this, believing that everyone has studied the topic already. The only thing that you need is for you to apply what you learned. So one of the expressions here that they're going to give you, the hint rather, they are saying if n is equal to 7, imagine this guy here is 7, right? So we are taking the case where n should only be a positive value. So if n is taken to be a positive value, meaning we can have something that looks like this. This is 1 plus, this is x over k to the power n. They said the coefficient of x and x squared are equal. That's what they said, right? So now we're going to have the expression looking like this. N choose r, then we have 1 to the power n minus r, then we have x over k to the power r, should be the same as this is x, right? This is what we are going to have. Then the other side we have n. It's like we're trying to get the term that has x, and also here we're looking for the term that has x to the power 2. So we're going to have this other part here, the first term. This is n minus that. Then we have x over k. This is to the power r. We also equate this to x to the power 2. Yeah, it's like your question number 13 from your tutorial sheet. There are those questions where they are saying find the term that has x to the power something, or u to the power something, or t to the power 7. Yeah, so that's what you have. So we want to get the r for the term that has x, and also the r for the term that has x squared. So according to this, we are going to get the portions that have x alone. So the only time when you see x is this part here. So x is raised to the power r. We equate it to x to the power 1, right? Implying that r here is equal to 1. That's what you have. On this part, you have x to the power r is equal to x to the power 2, meaning r is equal to 2. That's what you get. Then from here, we're going to go back and replace wherever there's r in these two expressions. We had this expression and this expression. Wherever there's r, we put these numbers that we're from getting. So we'll have n choose 1. Then we'll know, so this is 1 n minus 1. This is x over k, right, to the power 1. And also this side, we're going to say we have n choose 2. This is 1 to the power n minus 2. This is just x over k to the power 2. Now, they said the coefficients. So here I'll just, this part is the same as a 1, right? It doesn't change anything. Same applies. So I'll just get n choose 1. Ignore the x, meaning you just have 1 over k. So in case you're wondering why are we ignoring the x, I'll write it here and explain why we're ignoring it. This is a 1, so we'll have 1 over k squared. Then there's x squared. They mentioned that the coefficient of x, what's in front of x, this should be the same as what's in front of x squared. So we're saying n choose 1 multiplying 1 over k should be the same as n choose 2 multiplying, where is the k squared coming from? Because this was x over k to the power 2, which simply gave us x squared over k squared. I'm just removing x squared, so I'm remaining with 1 over k squared. That's where the 1 over k squared was coming from here. Yeah, so we have 1 over k squared. These two are supposed to be the same. That's what they mean by the coefficient. So if that's true, then we are able to solve this part. This is n choose 1, which is n factorial. This is what you get. And this is a 1 factorial. We're having 1 over k here is equal to n factorial. Then I have n minus 2 factorial, then I have a 2 factorial, then this is just 1 over k squared. So you are able to see that n factorial and n factorial can cancel, right? Here and here, or rather I can just say, I can break down this part. This is just going to be n factorial. There's a k down. This is the same as n minus 1 with a factorial with a k in front here is equal to n factorial. This is a k squared and a 2. 2 factorial is 2, right? So 2k squared, I'll write them here. Then I'm remaining with n minus 2 with a factorial. The guy on top, here you can break down the guy on top is simply n and n minus 1, right? Then here I'm having a k and my n minus 1 factorial, so that this part cancels. Also this side, you have n minus 1, then you have n minus 2, until we see the guy which is in the denominator. 2k squared, then this is n minus 2 factorial. This cancels, leaving us with n over k is equal to n minus 1, then there is a 2k squared. We can cross multiply. This is going to be 2nk squared is equal to kn, and you're having n minus 1. There's an n and there's a k, so n and k can cancel this side, n and k can cancel this side, meaning 2k, 1k, the k that remains, is equal to n minus 1. This is what they wanted. Hence, you write hence what? Hence shown. This is what they wanted us to get, right? Remember this part here. That's what they wanted us to show. We have gotten it. Then they are saying if n is equal to 7, determine the value of k. So we have 2k is equal to n minus 1. Wherever there's n, we put what? A 7. So this will be 2k is equal to 7 minus 1. This is 2k is equal to 6 divided by this, meaning your k is equal to a 3. So that answers your question number 1, the first part, this guy here. So if you notice, the questions are a little bit jumbled because I got them from different past papers. Yeah, so that's the reason why you're seeing them jumbled and stuff. So that's how you were supposed to do the first one. And number C here, they are saying find the term containing x squared divided by y squared in the binomial expansion of this, right? That's what they want. So the expansion has y they want the term that has, they're saying the term that has x squared over y squared. So that's what they want, the term that has x squared over y squared. So this is the same thing like your question 13 again. They're simply asking you to get the term that has this. The same way you did number 13 is how you do this guy. So we have 8, choose r, we don't know the r. We'll say the first term, which is x over y to the power 8 minus r. Then we have negative y squared over 3x squared. Then we are having this to the power r. Equate it to what they want us to get. This is this part here. That's what we need. Then from here, you can choose to either focus on x or y, depending on what you want, because both x and y are raised to the same exponent. So we are going to write, I'm going to use x, so I'm going to get anything that has x with the powers, of course. So this is x to the power 8 minus r. Then down here, there's this x squared to the power r as well. So there's x squared. The reason why I'm putting it down, because it's down this side, it's a denominator. This guy is a numerator, and I'm putting them like this. I will equate them to this x which is on top, and this is going to be the same as 8 minus r, the exponent of x. Down, this is the same as x to the power 2r. This is x to the power 2. Then this, the bases are the same, so I can just subtract the powers here. This is x, 8 minus r minus 2r is equal to x to the power 2. Then from here, I can just say 8 minus r minus 2r is equal to a 2. This is now going to be 8 minus 3r is equal to a 2. This becomes 8 minus 2 is equal to a 3r. This is a 6. I'm having a 3r there. Divide by 3, meaning r is simply equal to a 2. So if r is equal to 2, meaning we're having what? R plus 1. So this is actually 2 plus 1. So it is the third term that has x squared over y squared. That's how you are supposed to do the question. to get the term that was x squared over y squared. If you wanted, you would have used y. The answer will still be the same. So focus on things that have y. So I would have used this expression here. Wherever there's y, so there's y down here. So I'll write the y down. So there's a y, it's down there. 8 minus r. There's a y here on top. Forget about the negative, just get the y. Y to the power 2 raised to the power r. It's simply that. 1 over, there's a y down here, which is y to the power 2. Get them with respect to the position where the letters have been put in the expression. So this would have given us y 2r minus 8 minus r is equal to, this is y to the power negative 2. Equate the powers again, you get 2r minus 8 plus r is equal to negative 2. This would have been 3r is equal to, this goes this side, it will be 8 minus 2, that's a 6, divide by 3. You see that the answer is still the same. You're still getting that it's a third term. So that's how you were supposed to do this question here. The same thing like question number 13. So all these things here, you've done them before. They're just going to be twisting them to try to see if you can apply the principles you learned. Number question 2, given that n is a real number, solve the equation this is like question 6 from your tutorial sheet. So which one is big between n plus 2 and n? N plus 2 is big, right? So we're going to reduce it to be n plus 2. Subtract 1 from here, it becomes n plus 1. Subtract 1 from here, it becomes n. Then put the factorial. Then now you have 12, n factorial. You can cancel the n factorial. This is now n plus 2. And you're having n plus 1. Then this is equal to a 12. Then you can expand this. This is n. Then 2n. Then plus a 2 minus a 12 is equal to 0. This is n factorial. N squared. This is 3n. Minus a 10 is equal to 0. From here, the product is simply what? Negative 10. The sum is simply a 3. What factors can we use? The numbers such that we multiply them, they give us this. We add them, they give us a 5. A 3. We can use these 2. So we'll have n squared minus 2n plus a 5n minus a 10 is equal to 0. N, then we have n minus 2. This is plus 5. This is n minus 2 is equal to 0. So we have n is equal to negative 5 and we have n is equal to 2 when you're done solving, right? We know that n can never be negative, so we'll go with the positive one. We discard negative 5. So the answer to this question is that n is equal to 2. Because they say it's supposed to be a natural number, a countable, possible, only positive. So that's what you get on number 2, the first part. Hope this makes sense. Okay, so this is n is equal to 2. That's what you have. Okay, so I'll leave this here, but for the next question here, I'll do it on a different board. They want us to get there. They're saying in the expansion of this, find the coefficient of the term involving x to the power 3. We cannot get the coefficient without getting the term that we're dealing with, or rather the r value. So this is simply going to be the same as this. They want the coefficient of x to the power 3. Anything that has this, so we have a 2x, then we have minus 1 over 2x squared. So this is 2. This is 12. So we'll have 12, choose r. This is 2x, then we have 12 minus r. Negative 1 over 2x squared. This is that. Equate this to x to the power 3. We want to get the r first. That's the reason why we're doing this. So just get the parts that have x. The parts that have x is just x to the power 12 minus this. Then there's this x down there. X squared with the r. There's an r waiting there. So it will simply be this. From here, we can simply have x. Subtract the powers because the bases are the same. This is minus 2r. This will be x to the power 3. Then this will give us 12 minus 3r is equal to 3. Then from here, this will be negative 3r is equal to, this is a 3 minus a 12. So this will be negative 3r, negative 9, negative 3. So r is equal to a 3, right? So you know you're dealing with the fourth term because nth term is r plus 1. So this is just 3 plus 1. So we are dealing with the fourth term, whose r is 3. We can now proceed and get the term. So we are having the term now. So the term, if we get it, it will be, there's a 12, the r is a 3. The first term is 2x. 12 minus this, that's a 9. Then we are having the second term, which is negative 1 over 2x squared to the power, this is a 3. So 12 choose, if you solve this, this is 12 factorial, this is 12 minus 3 factorial and 3 factorial. This is 2 to the power 9 with x to the power 9. This is negative 1, this is going to be 8, x to the power 6. Because we're multiplying everything here to the power 3, right? So none of the negative is being preserved. Yeah, so please make sure you put it like this. So the whole answer will be negative because of this negative. We are having a 12 factorial there on top. This is a 9 factorial. 3 factorial is a 6. Then there is 2 to the power 9. Then you have x to the power 9. Then we're having 1 over 8 x power 6. We can reduce things that are reducible here. Things like there is 2 to the power, this is like 2 to the power 3. 8 is the same as 2 to the power 3, right? So 2 to the power 9 over 2 to the power 3, this is the same as 2 to the power 6, right? Because the bases are the same, so 9 minus 3, this is what is giving us this, right? If you reduce that, we get this. Then you know to say 12 factorial is the same as 12 by 11 by 10, then by 9 factorial. So that the 9 factorial can go. This is 2 to the power 6. X's, we have x to the power 9 over x to the power 6. So this can subtract to give us a 3. So we have x to the power 3. The 9 factorial can cancel. So we're having, this is going to be a 12 times 11, then times a 10, then times 2 to the power 6. Then divide it by 6. Okay, so now if you don't have a calculator and you're working this out, what are you going to do? Yeah, so you multiply this. This is going to give you 120. Or you can reduce things here, guys. You can just reduce it. Yeah, so 6 there is 1, 6 there is 2, right? Yeah, you can just multiply. This is 22, multiply by 10, that's going to be, this is 220. Then there is a 2 to the power 6 and x, this. Yeah, then you know 2 to the power 5 is 32, right? So you're just saying 2 by 2, that's a 4. You know 2 by 2, that's a 4. Then 2 by 2, that's also a 4. This is a 16. This gives you a 64, right? So we're having 220 times the 64, x to the power 3. So we're multiplying this. This will give you 220. Then there's a 64. This will be 0. That's 8. That's going to be 0. Yeah, that's going to be a 12, remainder 1. This is 12, that's 13, so this gives us 0, 8, 0. This is a 4, 1, is it? We're having a 0, that's 8, 9, 10. And put this guy, so we're getting this. Let me just check. 220 times the 64. Yes, we're getting a 14, negative 14080 x to the power 3. The question is asking for the coefficients, right? So coefficient of x to the power 3 is negative 14080. So this is what they wanted. This number there, that's a coefficient. So hope this is okay. Hope this helps a bit. So you notice it was a lot of work. Then the next thing here, they're asking for, they're saying we expand this until we reach x to the power 3. It's a series. So this is a binomial series. The valid region, so we can just put this in terms of, this is 1. If you think about it, this is just 1 plus. So this is the 1 over you have 1 plus x over 2. This is the same as 1 plus x over 2 to the power negative 1, right? The valid region is just modulus of whatsoever is here, then less than 1. We can factorize. This is the same as half times x less than 1. We can factor out the half. Then this is less than 1. We divide by half. We divide by half, meaning modulus of x is less than a 2. So this is what you get as your valid region. So I've just solved the last question here in advance. This question here, I just wanted to do it in advance because it's very straightforward. Yeah. Then when it comes to this question where they're asking us to expand until we reach the term x to the power 3, this will just be, so we're getting it from here. Remember the formula we're using, 1 plus a to the power n is always going to be 1 plus na plus n, then n minus 1. There's a 2 factorial, which is just that, a squared, n minus 1, then we have n minus 2, a to the power 3, then we have 3 factorial. It goes on and on, right? But this is just what they want, so we'll end there. Then we can now do the replacement, 1 plus x over 2 to the power negative 1. This becomes 1, negative 1, x over 2, then plus, there's a negative 1 minus 1, 2 factorial is a 2, x over 2, negative 1, negative 2, and negative 3, 3 factorial. This is the same as x over a 2, then the power 3. So this will be 1 minus x over 2. This will be a negative 1 and a negative 2. So these guys will be giving us a positive 2 divided by these 2. So they'll cancel. This will be x squared over a 4. Here we're getting 3 factorial is a 6. The guy on top here is 6 with a negative. So 6 and 6, that's going to be negative. Then this will just be x to the power 3 over 8. So technically, this is what you get as your answer up to the term that has x to the power 3. This is where you end from. So this is what you have. That's what you are supposed to get for this question. Then question 3. Question 3, they are saying, find the coefficient of x squared in the expansion of. So this question, in case it was not clear, the question is 1 plus x to the power 2 over, this is 1 minus x to the power negative 3. Right? So this is the question. This is what I should be able to see from there. So if we solve this, we are given a 1 plus x. This is question 3. 1 plus x to the power 2. Then we are having 1 minus x to the power negative 3. This becomes 1 plus x to the power 2. Multiplying 1 over 1 minus x to the power negative 3. So we can change it. This is 1 plus x to the power 2. We change this and becomes 1 minus x to the power 3. Because we can change it with a negative, right? So it's supposed to be, remember when you say negative x, this is the same as what? 2x1, right? So we're changing it back. It's the same thing that we're doing here. The negative 1 times the negative 3. That's how it's becoming positive down here. So now this becomes something that you can solve using your Pascal's triangle. You solve this using your Pascal's triangle. You will get this times itself, right? You get 1 plus 2x, then plus x squared. And also you solve this one using the Pascal's triangle. It will be 1. This will be minus 3x. Then this is going to be plus. This is just 3x squared. Then lastly you have negative 1. Or is it x? I mean, this is x to the power 3. Then from here, so you notice the powers are both positive. So if powers are positive, we use the Pascal's triangle all the time. So I'll multiply everything by 1. This side, I'll have 1 minus 3x plus 3x squared, then plus x cubed. Then the 2x multiplies everything as well. It's going to be 2x minus 6x, then plus 6x cubed. Then I'm going to have minus 2x to the power 4. Then again I multiply with x squared. it will be x squared minus 3x cubed, then it will be plus 3x to the power 4, then minus x to the power 5. We gather the like terms. So the like terms here, according to the question, they just want up to the term that has x to the power, or they want the coefficient of x squared, So what has x squared in this expansion? So we just get things that have x squared, this and also this. That's all right. So we're just going to say 3x squared plus x squared, which is just 4x squared. So coefficient of x squared is simply a 4. The 4, the number in front, that's what they basically want. So this is how you do it to avoid making mistakes. That's what was supposed to be done there. Then number 2, the second part of question 3 is finding the term independent of x to the expansion of this value here, this expression here. So what's the term independent of x in 2x minus 1 over x? This is to the power 12. So you can try to pause the video to check if you remember or you understood how to get the term independent of x. So we said the term independent of x is the term that has x to the power 0. So we're going to have 12, choose r. Then we say 2x to the power 2, 12 minus r. Then we're having negative 1 over x to the power r. Equate it to x to the power 0 all the time. Then from here, you get only the things that have x. What has x on the left-hand side? There is x to the power 2 with a 12 minus that. Then there is x down here, x to the power r, equated to x to the power 0. Ignore the negative, ignore the 1. But we are taking x to be in the denominator. It's down, right? Now we're putting it down this side. Then from here, we will know to say this will be x. This will be 24 minus 2r. Then minus r, because the bases are the same, right? So the powers will deduct or subtract. We have this will be 24 minus 3r is equal to 0. This is 24 is equal to 3r. Divide by 3, meaning r is equal to what? 8, right? So if r is equal to 8, meaning we have 8 plus 1, so this is simply the 9th term. That's basically what you have. So the 9th term is the term which is independent of x in this expression, if you were to expand it. So I hope that answers the question. You just want the term. Then question 4, I put this guy here deliberately because these are the type of questions you'll find from tutorial sheet 4. On the last question, number 18 going down. Yeah, so you have to know this. And remember how they were giving you free marks in quiz 2. In your test 1. There is some question where they were asking for a simple domain. They were giving something like, after you compose the functions, right? They were giving something like 7 marks. So let f be a function defined as follows. This is what you're having. This is a rational function. State the domain and the range of f. So the domain here is just going to be x is all real numbers. You solve this down part. So x should not be equal to plus or minus 3. The numbers that can make the down part to be 0, right? If you solve x squared minus 9 is equal to this. X squared is equal to 9. Square root both sides. X cannot be equal to this. So these are the two numbers. So just this, that's the domain. Even negative 3, because if you put negative 3 there, it's going to give you a 9. 9 minus 9 is what? Is 0. We don't want the down part to be a 0 because the function will be undefined. How about the range? The range is all real numbers, but y should not be equal to 0. This is a fixed case, provided what you are looking for is a case where the denominator is at a higher degree as compared to the numerator. It's bottom dense, so it's a fixed range. It's always going to be all real numbers, but not what? But not y should not be equal to 0. And if you are about to sketch this, this is your y, 9. There is x minus 9. So your vertical asymptote are the two numbers that you are not accepting in the domain, plus or minus 3. Then the horizontal asymptote is the number that you are not accepting, is the number that you are not allowing on the range, which is just a 0. X-intercept, do you have an x-intercept? None. Do you have any y-intercept? Yes. So y-intercept, we have when x is 0, y is simply equal to -1. So if we were to sketch this, we're saying we're not allowed to touch -3 on the x-axis, and also we're not allowed to touch a 3 this side. That's what you have. But we are allowed, and we're also not allowed to touch this guy. This is y is equal to 0. This is the y is equal to 0, the horizontal asymptote. But we are allowed to touch the y-intercept at -1. So -1, we're supposed to touch it there. So the graph here will simply come like this, turn this side. Then the other twins will simply be in this direction and in the other direction. So this is how the sketch was supposed to be. If you want, you can test 9 over x squared minus 9. Try to put in a number, let's say -4. If you put -4 there, this is going to be 9 over 16 minus this, which is just like a 7. So when x is negative after -3, the y values are positive. Now it's up there. Then the same applies here. If you try to put anything big, let's say 4, it will be the same outcome. Yeah, so that's why the graph is supposed to look like this. Then here, we want to solve this inequality, and whenever we are told to solve such an inequality, remember, this is already straightforward. There's a 0 this side. There's nothing that we can or we should bring on the left hand side. It's already in a proper way. We'll just have to solve the numerator and the denominator. So this is x squared minus 16. Then I'm having x minus 1 to the power 2. This is less than 0. That's your question. So here we'll solve the top part. The top part is x squared minus 16 is equal to 0. X squared is equal to 16. Square this side, square this side. X can either be plus or minus 4. The bottom part, x minus this squared is equal to 0. Square root, x minus 1 is equal to 0, meaning x is equal to 1. So we're having these 3 numbers that are going to demarcate the whole number line into these parts. So this is what we are having. We are supposed to test to check which region is going to be acceptable, because we have these two guys here, x squared and 16, and we have x minus 1 then squared. So we know this is always going to be positive despite what you are doing, right? This guy here, because anything you choose, -5, anything you pick, -3, anything you pick here, let's say 2, anything you pick, the outcome for this guy down, because of the square, is always going to be a positive outcome. Then for this one here, if you put -5 there, squared, that's a 25. 25 minus this, the answer is positive. You put -3 there, that's a 9. 9 minus this, the answer will be negative. The answer here will be negative. Unless you put 5, that's when it becomes positive. This and this is a positive, that's a negative, that's a negative, this is a positive. We want where this thing is less than 0, meaning where it's negative, which is this region and that region. So we'll just take it to be the solution set will be x should belong to, we're saying -4 up to what? Up to what if you put 1? Let's see the behavior when you put the 1 there. When you put a 1, the whole thing becomes undefined, so 1 is not acceptable. So it will be up to 1, then union, we have to remove 1. So this is what you get. We are not including 1. We know it's supposed to be this region here in the middle, right? But 1 is not part of the set. Why? Because when you put 1 in the expression, the top guy is okay. The top guy will give you what? This is 1 squared minus 16. That's going to give you something like a -15. The down part gives you 0, because that's 1 minus 1. So you get a 0. We don't want the down part to be 0, because the whole expression will be undefined. That's the reason why we are saying -4 to 1, union 1 to 4. To show that if we are to represent this on the number line, we need to have a hole at 1. It's supposed to be like this. It's supposed to be, these are open. They're all open. Yeah, so this is how we can show to say we're just counting this part. Here we skip and also count the other part. So hope this makes sense. I just did this deliberately to see if people are okay with tutorial sheet 4. Look at this other one here. Yeah, so this one here, we said if there are 2 square roots or radical expressions, we take 1 on the other side. This is something like on your tutorial sheet. Yeah, so this is 3x, so this is 3x plus a 5, and I'm having a plus. This is x minus a 1, this is equal to 2. So we said you have 3x plus a 5 is 2 minus root of x minus 1. You can square both sides. When you square both sides here, this will be 3x plus 5. Then when you multiply this by itself, to avoid making mistakes or skipping all the steps, no wonder they say show all your working. You need to show every step, right? Because the examiner or the marker is not in your mind to see the manipulations you did. So you need to have a 4. Then this will be 2 root of x minus 1. This will be minus, there's a 2, x minus 1. This will be minus plus. So this will be that. This times that, right? We take everything that is not under the square root on the left hand side. This is 3x plus 5 minus 4, then minus x plus 1 is equal to, when you do this, this will be something that will give you something like this. There's a 4 there, so it's supposed to give you a 4 because they are like terms, right? These two are like terms. Then this is just going to be equal to, this is going to give us 2x. Then this is 5 minus this. 5 minus 4, that's a 1. 1 plus 1, that's simply going to give us a 2. Okay, I really hope this is okay. Hope I've not made any mistake anywhere. Because now we can divide everything by 2. This will just be negative 2. Then I have x minus 1. I can square both sides so that I cancel this again. Not I can, I should. You always square both sides whenever you're remaining with 1 radical 1 square root, so that you cancel it as well. This multiplies itself, it will give you 2x then plus 1. This is going to be a 4. This is x minus 1. This now turns into a quadratic, something that you are comfortable with. This will be 4x minus 4. We take these guys on the left, x squared minus 2x, then this becomes 5. This is 0. So we try to solve this. I'll go straight ahead to use the Shimabasi equation to avoid wasting time. Then this is going to give us 4 minus 4. This is just a 5, is it? This has to give me 2 and a 1. So I'm trying to figure out how this is supposed to come out. Plus this here is simply 4 minus 20. That's negative 16, right? So this is a 2. So since we learned complex numbers, this is just plus 4i, this is just a 2, so x is the same as this. I can just divide everything by 2, right? So it will give me something like 1 plus 2i. So I'm having two answers. There's x, which is 1 plus 2i, and there's x, which is 1 minus 2i. So these are the two complex roots of the expression if you were to solve this, right? Yeah. Then this, I think I mistakenly added this again. We have done this already, so I'll skip it. This is, I mistakenly did that addition twice. When you have this type of expression here, this inequality. So under this inequality, we're going to simply redefine this. And when we define it, we're going to have 3x plus a 2. This is x minus 1 to be less than or equal to 3 over 4. Or we can say, if we have 3x plus 2, so just go direct, x minus 1, this is going to be greater than or equal to negative 3 over 4. So this is how we always redefine something from a modulus type of inequality. So we're simply going to have two cases, so just rewriting this, we'll have less than or equal to 3 over 4, or we'll have 3x plus this, x minus 1, this is going to be greater than or equal to negative 3 over 4. This is what you always do. This is a simpler way to go about it. And here when you do this, remember under inequalities you cannot cross multiply, so we'll just have to move everything that's on the right to come on the left. So you have 3x plus 2, x minus 1 minus 3 over 4 greater, this is less than or equal to 0. This is 3x plus 2. This is x minus 1. Then plus 3 over 4 greater than or equal to 0. From here, the common denominator is x minus 1 with a 4. This will be 12x then plus 8. This will be minus, the negative is multiplying everything. So it will be minus 3x and plus a 3 less than or equal to 0. So we're solving both of them at the same time. There's a 4. This will be 12x plus 8. Then plus 3x minus 3 greater than or equal to 0. So on top we're having 12 minus this. So 12 minus 3, that's going to be 9, 8, 9, 10, 11. So that's simply 11. Down we're simply having 4x minus 4 less than or equal to 0. This side we're getting 12 plus this, that's a 15. 8 minus this, that's a 5. Yeah, we have x minus 4 is greater than or equal to 0. We solve the numerator here, we'll get x is equal to negative 11 over 9. Solve the denominator, we get x is equal to 1. We get to solve the upper part. This is going to give us x is equal to 5 over 15, which is the same as 1 over 3. Then the down part still gives us the same as x is equal to 1 because they're the same thing, right? Yeah, so now we get to test. The smaller one is 11 over 9, the smallest one, then followed by the 1 over 3, then followed by the 1. Put the 1 this side. Yeah, so now we get to test in between to check under which part we're going to get the correct solution set. The best way is to just get 9x plus 11, then the 15x, then minus 3. Is it minus 5 or something? Should be minus 5. Oh, this has to be positive, guys. It had to be positive because it's 8 minus 3, right? That's 5. That's positive 5, meaning this will carry a negative. And if it carries a negative, meaning it will be where? It will be somewhere here still, right? Yeah, still going to be that. So that's positive. This here is a positive 5. Then we're having the other guy, which is 4x minus 4. Yeah, so I can test any number this side. I'll use negative 10. Any number here, this is 0. What? This is 0.3. I can use something like a 0.4. Should be somewhere here. Yeah, then in between here I can just use a 0. After this I can just use a 2. So if I use negative 10 here, that's going to be a negative. Negative 10 there, the outcome is negative. Negative 10, the outcome is negative. So this whole thing will be negative. I choose a negative 0.4 here. So that's 9. Since we don't use calculators, just multiply the 9 times the 4. That's 36, right? So go back to the decimal place. So this is negative 3.6. Negative 3.6 plus 11, that's going to give us a positive 15. And this guy here, that's going to give us a 60. So it's 6, negative 6. Negative 6 plus this, the answer is negative. This times that, that's going to give us negative 1.6 minus this, the answer is negative. So this is positive. 0, that's positive, positive, negative, negative. Use a 2, that's positive, positive, that's positive, positive. We want where this thing was what? We want where this whole thing is. Okay, I need to use this. I was supposed to use the original inequality because I combined all the solutions, right? Okay. We want to get where it's positive. So modulus makes everything positive, right? I need to get the correct answer. I need to check this. So let me just redo this. The letters, the numbers are okay, but I need to use the original thing. Yeah, so here, sorry, pardon the mistake. We need to use the original expression, which is the 3x, then plus a 2, then over, this is x minus 1. Want to check if the left is actually going to be less than or equal to the right hand side, right? So if I put a 10 there, that's going to give us negative 30, negative 30. Plus that, that's negative 28. I put a negative 10 down, that's going to be a negative 11, negative and negative. So if I divide, so I'm just going to do it quickly because of the time I've lost when I was doing the wrong stuff. This is 2.5. 2.5 is not less, so this is force. This side is force. Then I use this guy here, the 0 point this, so that's what we said, 3 times negative 0.4, then plus 2, that's 0.8. Yeah, 0.8. Then down I'm having, this is negative 1.4. So divided by 1.4, that's going to be that. It's a fraction. 4 over 7. Yeah, so 4 over 7 is 4 over 7 less than or equal to 3 over 4. So in fraction, in decimals, this is the same as 0.57. Is it less than or equal to 3 divided by 4, which is 0.75? This is less, right? So this is true. I put a 0 there, I'm getting a 2. Is 2 less than or equal to 0.75? No. False. I use a 2, that's simply 6, 7, 8. 8 over 1, is this guy less than or equal to 0.75? No. That's false. So the only solution is between negative, so x should come from this guy here, 11 over 9, negative 1 over 3. It's closed because the inequality was less than or equal to. Yeah. Then the next question is also straightforward. It's a quadratic inequality. So we solve the quadratic, put an equal sign first, then solve it. Then when you do that, you test when you're done. Plus 13x minus 5. Put an equal sign. The product here is what? Negative 30. Then here, so I'm going to have, this is what? This has to work. The sum is 13. So what numbers can I multiply? We multiply them, we get a 30. We subtract them or add them, we get a 13. So this will just be a negative 2 and a 15. Yeah, so we can have negative 2x, then plus 15x, then minus 5 is equal to 0. That's going to be a 2x, then I'm having 3x minus 1, and plus a 5. This is going to be 3x minus 1. Yeah, so when you solve this, it's going to give you 2x plus 5 is equal to 0, and 3x minus 1 is equal to 0, giving you x is equal to 1 over 3. And x is equal to negative 5 over 2. So we test now. Yeah, so I'll just put them here for the sake of time. Negative 5 over 2, so that the video does not become very long and boring for you to watch. So it's almost done, guys. Just one more question, then to be done. So we test. I can use a negative 3. I put negative 3 there. That's going to be a 9. Positive 9. 9 by this is something very big, so this is true. I use a 0 there. 0, 0 is 0 greater than, that's false. I use something, let's say 1, this, that's true. Yeah, so the answers are simply supposed to be from negative infinity to negative 5 over 2, open, union from 1 over 3 up to positive infinity. So this is where the x must come from. Yeah, so this is the answer. In the last question, I'll give this as a task so that you just attempt to see if you actually watched the video reaching this point. The only thing to do here, if you have a modulus inequality, change the inequality here to an equal sign, then square both sides and solve. Get your two answers, then test. Then here, take this on the other side. Take this on the other side. It will be 2 over x minus 3 minus 3. Then you have 2x minus 1 is less than 0. Solve this. Then you test. Yeah, so this part here was not part of your course outline. This is an odd topic, mathematical induction. Yeah, so I want to do that. Then also, you can attempt this. This is also your task. Try to show me what you've learned so far to see if you're able to apply. Yeah, try to send your answers on WhatsApp. Let's see the progress that you are making.